Hi, welcome back. In our last class, we discussed about how we can reduce the domain of the function sine from the set of real numbers to the set minus pi by 2 to pi by 2 closed interval to make the function sine invertible. Now the question is it the only domain minus pi by 2 to pi by 2 closed interval for which the function sine is invertible, or there exist some other domains so that we can consider the function sine as invertible? Let's see whether we can find those other intervals or not. So now, if we see the function sine in graphical representation, it looks like this one. So this is origin, this is positive direction of x-axis, this is negative direction of x-axis, this is positive direction of y-axis, this is negative direction of y-axis. This where sine attains the maximum value is pi by 2. Then this is pi. Here it attains the minimum value. This is 3 pi by 2, minimum value is minus 1 and maximum value is plus 1, and then it is 2 pi. So 3 pi by 2 is here, we can write 3 pi by 2. Similarly, in the negative direction of x-axis, sine attains the minimum value minus pi at minus pi by 2. Then the value 0 at minus pi, then the value maximum value, that is 1, at minus 3 pi by 2, and again the value 0 at minus 2 pi. So the question is it the only range minus pi by 2 to pi by 2 where the function sine is invertible? Yes, this is true, but at the same time there exist some other intervals where the function sine is invertible. One such interval is pi by 2 to 3 pi by 2. If you see in this interval pi by 2 to 3 pi by 2, the function sine is 1 1 and onto both. Why it is 1 1? If you take any two different values in the interval pi by 2 to 3 pi by 2, you will always get different values of sine in the y-axis. So that's why the function sine is 1 1, and it is onto as well because if you take any value from minus 1 to plus 1 along y-axis, you will always find an angle between pi by 2 to 3 pi by 2, so that the value of sine of that angle is actually the value which we choose from minus 1 to plus 1. So we see not only minus pi by 2 to pi by 2 is the only domain, the domain of the function sine for which the function sine is invertible. There are other domains like pi by 2 to 3 pi by 2, similarly like minus 3 pi by 2 minus pi by 2. In that range also the function sine is invertible. Now, out of all these different domains where the function sine is invertible, we take the domain minus pi by 2 to pi by 2, that is called principal value branch. The domain of the function sine becomes the range of the function sine inverse, right? Now let's see in the tabular form for all the other functions including sine inverse, that is sine inverse, cos inverse, tan inverse, sec inverse and cosec inverse, what is their defined domain and range? With range means it is a principal value branch. So here we write the trigonometric function. So we'll write here not trigonometric function, it is an inverse trigonometric function. Sorry. Then here is the domain and here is a range with principal value branch. Let us consider the function sine inverse. What is the domain of sine inverse? It is -1 to 1 closed interval, and the range is -π/2 to π/2 closed interval. The function cos inverse, its domain is just like sine inverse, -1 to +1 closed interval, and the range is 0 to pi closed interval. The function tan inverse is the domain. The domain of the function tan inverse is any real number or the set any real number, and its range is -π/2 to π/2 open interval. Then the function cot inverse, its domain is R, just like tan inverse, and the range is 0 to pi open interval. The function sec inverse, it has the domain, sec inverse has the domain, the set of real numbers minus the open interval -1 to 1, and its range is 0 to pi closed interval excluding the element π/2. And cosec inverse, its domain is similar to sec inverse, that is the set of real number are minus the open interval -1 to 1, and its range is the closed interval -π/2 to π/2 excluding the value 0. So we give it the set notation. So what we see, that if we reduce the domain of the function, domain of the trigonometric function sine, cos, tan, sec, cosec, cot, then we can make the function invertible. Now the domain, that reduced domain of the function, trigonometric functions, becomes the range of the inverse trigonometric functions, right? And we also discussed there are several ranges possible to have a trigonometric functions to become, the other way I should say, it is possible to have different ranges of a inverse trigonometric function, but the values in this range is called the principal value branch of the range. In our next class, we are going to discuss about the different properties of inverse trigonometric functions. I have categorized the properties of inverse trigonometric functions into 9 different subcategories, and in our next class we will discuss about all these properties from property 1 to property 9 in details. Thank you.